Good evening, everyone. This is assignment related to mass spectrometer and ionization energy from IAL Chemistry Unit 1. In the first question, a sample of element X contain only isotopes which are shown. What is the relative atomic mass of X? So how we can work out the relative atomic mass? We have the percentage abundance for the each isotope. So percentage multiplied by mass, the percentage of the isotope. So this will be 68.077 multiplied by mass, which is 58, plus 26.223 multiplied by mass, which is 60, plus 1.14 multiplied by 61, plus 3.634 multiplied by 62, and the last one is 0.926 multiplied by 64, and that total will be divided by 100. So when we solve, it will come out as 58.760, and they mentioned to 3 decimal places. So B and C cannot be an answer because it is only 1 decimal place. So either A will be answer or D. When we solve, it will come out as 58.760. In question 2, how many orbitals are there in first 3 quantum shells of an atom? So total number of orbitals, first 3 quantum shells, we have 1s, then 2s, 2p, then 3s, 3p, and 3d. So s is having 1, 2s having 1, and 2p is actually divided into 3 2px, 2py, 2pz. Then 3s is there. Then 3p is divided into 3py, 3px, 3pz, and 3d is divided into 5. So this is 5, 3, 1, 1, 1, and then 3. So 5 plus 3, 8, 9, 10, 11, 12, 13, and 14. So total number of orbitals which are present in the first 3 quantum shells, that is 14. Because S is having only 1 quantum shell, P is having 3 quantum shells, D is having 5 quantum shells. So we have 1D, 2 of 3P and 2P, so it means 3, 3, 6. 6 plus 5, 11, 12, 13, and 14. That's why D is the right answer for question 2. In question 3, which element is in the P block and has an atom containing 2 unpaired electrons in the ground state? So when we check the periodic table, the position of these elements in the periodic table, so lithium is a S block element, carbon is a P block element, fluorine is a P block element, and titanium is a D block element. So either B will be answer or C will be answer. And what about carbon? Atomic number of carbon is 6, where atomic number of fluorine is 9. So when we write the electronic configuration for carbon, it will be 1s2, 2s2, 2p2. So electron in a box model, 1s, 2s, and 2p. So 1s it will have 2 electrons, 2s it will have 2, and 2p will have single 2 unpaired electrons. Whereas in fluorine, the electronic configuration 1s2, 2s2, 2p, 5. So when we draw the electron in a box model, So one S is having 2 electrons, 2S is having 2, 2P is having 5. So 1, 2, 3, 4 and 5. So there is one unpaired electron, but for carbon there are two unpaired electron and it belongs to P. So B is the right answer for this question. In question 4, the first 5 ionization energies of element in kilojoule per mole are given. The element could be, so how we can work out the element? We can check the number of electrons present in the last shell. So how we can check the number of electrons present in the last shell? We'll check the ionization energy 578, 1817, 2745, and then it's a big jump, which is 11,000. So it means that this element is having 3 electron in the outermost shell. So it belongs to group 3. So when we check the groups, sodium belongs to group 1, magnesium belongs to group 2, aluminum belongs to group 3, and silicon belongs to group 4. So that's why C is the right answer, as the first 3 successive ionization energies are similar, means similar in that sense they have a same trend. Like, but from third to fourth there's a big jump, so it shows that the shell completely changes. So it is having 3 electrons in the outermost shell. The structure question. This question is about the element chlorine. Give the electronic configuration of a chlorine in sp(d) notation for chlorine atom in a ground state. So chlorine atomic number is 17. So we have to arrange 17 electrons in chlorine. It will have 1s2, 2s2, 2p6, 3s2, 3p5. Write an equation for first ionization energy of chlorine. Include the thread symbol. So ionization energy means energy required to remove electron from neutral gaseous atom. So we should have a chlorine neutral in a gaseous atom, and we supply energy so that the electron is removed and it will form a chloride ion, positive ion, by loss of one electron. Explain the difference in the first ionization energy of chlorine and bromine. So when we compare, for chlorine, you will have less shells, electron will be closer. But for bromine, atomic number is higher than chlorine, so it will have more shells. Electron will be away from the nucleus, so attraction will be weaker. So what are the points we will include? Number one, so bromine is having more electron shells. Which result in greater shielding effect and so less force or less energy is needed to remove electron compared to chlorine. So these are the points we will include to explain why the differences when we compare. Chlorine is having a higher ionization energy than bromine, that will give us 1 mark. We'll mention the shielding effect and the greater distance, more electron shells are there, that will give second and third mark. Chlorine occurs naturally as a diatomic molecule. Draw a dotted cross diagram to show a bonding in a molecule of a chlorine. Show outer shell electrons only, so it belongs to group 7. So as it belongs to group 7, it will share one electron. Each chlorine share one electron, and unshared will be 6. And it's a dot and cross, so one we represent by cross, another one by a dot. Chlorine is gas at room temperature and pressure. Why chlorine has a lower boiling point? So what is the reason why chlorine is having a lower boiling point? Because it's having a weak intermolecular forces or London dispersion forces, so easy to remove or separate the molecules from each other, or little energy is being needed. A small amount of energy is required to separate the mo molecules from each other. That's why it is having low boiling point compared to that with other halogens. Next question. Chlorine has two stable isotopes. The isotopes have a mass number of 35 and 37 with a relative abundance 3:1. So one is 3 times compared to the other one. Or ratio 3:1 in terms of percentage, it means if one is 75%, the other one will be 25%. That will make the ratio 3:1. Complete the mass spectrum for a sample of a chlorine gas to show the expected molecular ion peak for chlorine molecule. So this is for chlorine molecule. So what are the number of the peaks we can have for a chlorine molecule? Because chlorine is having two isotopes. So maybe in a chlorine molecule, we may have both of them as 35. Like the both atoms are 35, so the sum will be 70. Maybe one of them is 35, another one is 37, so we'll get a peak at 72. And maybe both of them are 37, so we'll get a peak at 74. So we'll get a peak at 70, we'll get a peak at 72, and we'll get a peak at 74. But what about the heights for these peaks? When we compare the ratio, as we are plotting for chlorine molecule Cl2, the 35 is 25%, third and 30, as I mentioned here, 33:1, so 35 is 75%, and 37 is 25%. So when we plot the position, so the relative abundance, it's the ratio for 70 to 72 to 74, it is 90 to 60 to 10. So the heights, this is 90, this one is 60, and this will be 10 ohm. So this is how we got the relative abundance for chlorine. Molecule 70, 72 and 74. So the molecule 70 will be 90, for a molecule 72 will be 60, and for molecule 74 will be 10. And how we work out these peaks, like how we know one is 90, another one is 60, another one is 10 only. You can clearly see the ratio is 3 to 1 for the molecules. So when we mention this will be 75% and this is 25. That is 75% for Cl2. So half of 75. So that will be 75 divided by 2, which is approximately 37.5. And 37.5 multiplied by 2. In terms of molecule, so overall this is 75 in terms of, because Cl2 is there, and this one is 25 and this one is 75, and not 75 because one is there, so half of 75, that is 37.5, and half of 25 is 12.5, so that is equals to 50. So when we take the total percentage for the first one for Cl2, so it is 75 divided by the sum, which is 75 plus 50 plus 25. So 75 plus 50 plus 25, 150. So 75 divided by 150 is equals to 50%. 50% is for 1, and for 2 it will be twice of that. So you can write the peaks, like there are different ways to write this. You can write about, this will be 50, that is for 35, chlorine 35. When you check for the second one, which is 72, so 72, which is 50%, divided by 75 plus 50 plus 25. So 75 plus 50 plus 25, that's equal to 150. So 50 divided by 150, that's equal to 33%. So 33, and the last one, that is 25. So 25 divided by 150. So 25 divided by 150, that's equal to 16%. So you can use these numbers also. You can use like 50%, 33%, and 16%. The relative abundance, that will be the right answer. The exact one, it's 90, 60, and 1. Moving on to the next question. Question 6, the structure question. This question is about bonding structure and properties of element in period 3. A student plotted a graph to show the melting temperatures. So the graph is there for melting temperature. You can see from sodium to magnesium it increased, and aluminum this decreases. Then for silicon it's high, then phosphorus, sulfur, chlorine and argon. The student incorrectly plotted the values of one of the metal and one for non-metal. Identify this. So what is the mistake? Because what happened, group 1, 2, 3 should increase. So student wrongly plotted for aluminium and as well as for argon, because it is, you can see it is a decreasing trend. So for argon he make a mistake, so aluminium and argon are not correct. So group 1, 2, 3 and 4 it increases because the metal size getting smaller, the charge is increasing, and from group 5 onward it decreases because weak van der Waals forces. Explained with reference to the structure and bonding why silicon is having a very high melting temperature. So what is the reason why the silicon melting temperature is higher than others? So silicon, it's having a giant structure. That's one thing. So there are many bonds between the silicon atoms. So large amount of energy is required to change the or break the bonds. Aluminium has the greatest electrical conductivity of period 3. Describe how metals can conduct electricity. So how these metals can conduct electricity? These metals, they have free electron or delocalized electron, which can flow through the structure when potential difference is applied. Give a possible reason why aluminium is having a high electrical conductivity than sodium. So what is the reason? Aluminium belongs to group 3, so it is having more electrons, as aluminium tend to lose 3 electron and sodium only tend to lose 1 electron. So more electron in the structure. That's why electrical conductivity of aluminium is higher than sodium. Aluminium is extracted by electrolysis of aluminium oxide in a liquid state. Draw a dot and cross diagram to show bonding in aluminium oxide and show outer shell electron only. So it's an ionic compound. So aluminium tend to lose all of its valence electrons, so there will be a charge of 3 plus, where oxygen belongs to group 6. So each oxygen is having 2 electrons in the outer, 6 electrons in the outermost shell. So we should have 2 aluminium ion because the formula for aluminium oxide is Al2O3. So 2 aluminium ions and 3 oxygen, and each oxygen take 2 electrons. So this is a dot and cross diagram for aluminium oxide, in which each aluminium loses 3 electrons, so total it will lose 6. Give a reason why aluminum oxide must be in a liquid state before electrolysis can occur. Because in a liquid state or a molten state, ions are free to move. In solid state, ions cannot move, so that ions are free to move. In MCQ 7, the mass spectrum of a sample of element is shown. What is the relative atomic mass? So basically these are the peaks for this element. So how we can work out the peak of this? This region shows it's a molecule. Region show, because molecule group of atoms, you can see it is approximately twice. So it shows that this region is for molecule. If they ask for molecular mass, then we'll use this side. But they're only asking for atomic mass, so we'll use the atomic mass part only. So each block 1, 2, 3, 4. So this is 3.5, and this is 1, and I can take 1.9 or I can take 2. So 3.5, the height multiplied by, if they ask for molecular mass, then we'll use the molecular ion peak and their relative abundance. But they're asking for atomic, so we are taking that only, this part. So this is 31 and 32. This is between 31 and 32, so it is 31.5. So this is 31.5. So 3.5 into 31.5 plus this one is 31, 32, and this is 32.5. Or the second possibility, that one more thing, because what are the possibilities here? They mention the mass spectrum for sample of element. Element can be, so this is directly, it's an element, like example it can be chlorine, bromine, iodine, any element is there. We need relative atomic mass of this element. But what happened, why the peaks might be how, because what could be the reason? Maybe here one, because this is a mass to charge ratio, so maybe here the one electron is removed, and here we have a peaks for 2 electrons removed. So this is for charge plus 2, because in the question they mention here, I did not read the first line, the mass spectrum of sample of element. So this is a sample of element here. So if it's a pure element, they already specify, it means the higher peaks are showing that when one electron is removed, and lower peaks are showing when 2 electrons are being removed. So that's why it is 61, 62, 63. So this is 63 multiplied by the height, which is 46, plus 63, 4, 5. So this is 65 multiplied by the height, which is 20, and divided by 46 plus 20, so this is 66, because divided by the sum of the relative abundance. So what will be our right answer? It will come out as 63.6. Is it clear? Because they mention for element here, that's why this is for charge plus 1 and this is for charge plus 2, because it is half of it. If it is a molecule, like example, if it was a molecule, then molecular ion, so it can be half, it can be other value as well. Which species could be responsible for a peak at 32.5? So 32.5 for sulfur, sulfur is 32. So 32 divided by charge plus 1, so we'll get at 32. For copper, 63 with a charge plus 2, so 63 divided by plus 2, so it will be 31.5. For copper, 65 divided by plus 2, 2 plus, so that is 32.5. 5. So C is the right answer. Titanium 98 divided by 3. So we'll get for 98 divided by 3, we'll get at 32.6. So basically it's for copper. In question 8, which ion does not have electronic structure shown? So potassium, how many electrons it will have? It will have 18 electrons because 19 are there, it lost one. Calcium will have 18 electron. Titanium and scandium, when we check the atomic number for titanium, that is 22 or 21. Atomic number of titanium 22, yeah. And scandium is 21. So 18 electrons, because there are so 2, 4, 6, 8, 10, 12, 14, 16 and 18. So here it shows 18 electrons. So this is for potassium as well. This is for calcium as well. And when scandium loses, titanium atomic number is 22. But when it loses electron, it will not be 22, it will be 20 here. And 21 minus 3, so it will be 18. So this is not for titanium because titanium is having 20 electrons, so there should be 20 electrons in the figure, but we have only 18 electrons. As the question is, which ion does not have the electronic configuration shown? What is electronic configuration of nitride ion? So nitrogen is having 7, but nitride ion is having only 10 electrons because minus 3 took. So we have 10 electron, 1s2, 2s2 and 2p6. So D is the right answer because here we have 8 electrons, here we have 4 plus 7 electrons, 4 electrons and 10 electrons. Which equation represent the third ionization energy? So energy required to remove the third electrons, already 2 are removed and we are removing the third one in a gaseous state. So A is the right answer. In question 11, this question is about the structure of atoms. State the definition for orbital. So how we define an orbital? It's a region in an atom which can hold two electrons with opposite spin. A region where 95% finding, that's also correct. State the shape of s orbital and p orbital. So s orbital is spherical and d is dumbbell, in which they are asking for orbital, so we don't have to draw px, py and pz because each orbital maximum can hold two. When we say px is orbital, py is orbital, pz is orbital. So maximum number of electron in each orbital can be 2. And 2p is called orbit, which include 2px, 2py and 2pz. So this is orbit and this one is orbital. So 2p is the whole orbit and we have 2px, 2py and 2pz orbitals are present in. So we just have to draw 2px, y or z only p orbital. So S is a spherical where P is a dumbbell shape. About S, it is orbit or orbital, both are used. Like if I say one S, I will say 1s orbit, or I can use the term orbital because it's the same thing. It can maximum have 2 electrons. But for 2p, I don't say 2p is orbital. I will say 2px is orbital, 2py is orbital, and 2pz is orbital. Describe what can be deduced about the electronic structure of sodium from its successive ionization energies. So what we can deduce about the sodium from its successive ionization energies. So for sodium, it will the electronic configuration when we write, it will be one, because sodium belong it's having 11 electrons, so it will be 1s2, 2s2, 2p6, 3s1. So how many quantum shells are there? The total number of quantum shell, this is one quantum shell, two quantum shell, three. So there are three quantum shells or three shells, and it will have one electron in the outermost shell, and first electron is removed from the 3s orbital. The log of the fourth ionization energy of 6 elements are shown. So we have to take a log for sodium ionization energy. We have to take a log of this, plot the graph, and basically the on the y-axis we have log, and from the graph we will deduce the next part will be from the graph, use a graph, estimate the fourth ionization energy. So how we will estimate, because successive ionization energies are comparable for element. Here we have log of ionization energy, and we have elements such as oxygen, fluorine. How many are there? 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. Yeah, so oxygen will be here, fluorine, neon, sodium, magnesium. So I can start from here as well. So oxygen, fluorine, neon, sodium, magnesium, and aluminium. The values are from 3 to 4. So I don't have to exactly start from 0. I can start with 3, and even it's about 3 point. So because for scale to be more accurate, like example, if this is 3.8, as the smallest value is 3.87 and the highest is 4. So if this is 3.8, then this will be 3.9 or 3.9, 4, 4.1. So this will be each, because there are 20 boxes, so 2 boxes are equal to 0.01. So when we plot these results, what pattern we will have? It will be a straight line, approximately straight line. So like 3.87. So for oxygen it is 3.87. So this is 3.85, then 6, 2 boxes 6 and then 3.87, so it will be here 3.92, so 3.91 and 92 1 and for neon it's 3.97, 3.95, 96, 97. Sodium we don't know, 4.02, so 4.02. This will be for approximately here. And for aluminium 4.06, 4.01 and 4.0, because this is 4.5, this will be 4.1. Between them we'll have this aluminium and magnesium. A closer values are there. Then how we can reduce? So sorry, it is 4.05. Sorry by mistake. 4.05, 4.01, because this is 4.1. This will be 4.0. So 4.01 and this will be 4.02 and this will be 4.06. So when we draw a straight line, we can work out for sodium from this value. So we can reduce the ionization energy for sodium, but this will be log, like we'll have a log. Like example, if it is coming out as 3.9 approximately or 3.85. So if we are getting 3.85, but that is log of the ionization energy is we are getting 3.85, but we have to take anti-log. So how we take anti-log? So anti-ionization energy e raised to power 3.85. So we'll get the ionization energy in kilojoule per mole. Is it clear? Yes, Iftihar. Yeah, it is not ln, it is log. So you will take 10 raised to power 3.85. If it was ln, then I will take e, because I mentioned here it is log 10. So log 10 is there, so base is 10. Then suggest why the fourth ionization energy of a neon and sodium are similar in magnitude, even though they are in the different periods. So when we check the fourth ionization energy required, because the fourth ionization electron is removed from the same shell, that's why they have the same ionization energies. So when electron removed from same shell, the ionization energy will be similar. In question 12, a p block element in period 3 react to form an ionic compound. What could be the electronic configuration of ion? So period, it is a period 3, a p block element in period 3. So for question 12, and it has lost the electrons and it is forming an ionic. So when it is forming, it should form a stable compound. When it will form a stable compound, it should have a complete octet. Octet means 8 electron in the outermost shell. So when we check which of them is completing the octet, A is not completing the octet. A is still in the third shell, the third period it is having, because they mention a p block element. How it will be a p block element? Belongs to period 3. So what are the p block element? P block elements like group 3 is there, group 4 is there, group 5, group 6, group 7, and group 8. These are the p block elements. So p block element group 3 is a metal, rest 4, 5, 6 are non-metal. So if it was a group 3 metal, then it should lose all of the valence electron, because group, if it was a third period element, it should lose all of the 3 electrons, so it should not have any electron in the third shell, because if it was a metal. And if it's a non-metal, it will gain electron to complete octet. So even it is like group 4, it will be 3s2 and 2p2. If it is group 5, it will be 3s2, 2p3. So 3s2, 2p, 3p4, 3s2, 3p5, and 3s2, 3p6. So it will complete an octet and gain the stability. So B is the right answer. The third period they are asking. Third period, a P block element from third period. So third period is from potassium onward. Yeah. So potassium and calcium are group 1 element. Potassium is group 1, calcium is group 2, and then aluminum is there. Not aluminum. So this is a periodic table that is the first period, the second period, the third period started with sodium. So, and these are the S block element. So it can be aluminum, silicon, phosphorus, and so on. In question 13, the period 2 element with the highest melting point. So period 2 element with the highest melting point, when we check the elements in period 2, lithium, because what happened when we move across group 1, 2, 3, and then group 4, it increases. So carbon will have the highest, followed by boron, then beryllium, and lithium. So what are the options we have? We have carbon here as an option. That's why C is the right answer. So this was assignment related to mass spectrum and ionization energy. Next session we'll continue this discussion.